Hey guys, welcome to Code Talk. Today we are solving the problem asked in the interview of Amazon and JUSPAY. Okay, so the problem statement is find the equilibrium index of an array, and the description over here says that we have to find such an index in an array where the sum of the left subarray is equal to the sum of the right subarray. Okay, if you guys want to read the description, you can read it over here, but this is what it means in simple words. And here they have provided an explanation. This is an array, and these are the equilibrium indexes 0, 3, and 7. Okay, so let's check out for any one of the index that if the conditions are satisfying or not. Let's take this index. This is the left subarray, this is the right subarray. So what will be the addition? 2. Here addition is also 2. They both are equal and the condition is getting satisfied. So the intention for this, we'll see only the efficient approach. Okay, coming over here, what I will do is I'll create two more arrays. One will be left, other will be right. What will left store? Left will store all the elements, the sum of all the elements towards the left of that particular index. Obviously the first element over here will be 0 because there is no element present to the left. And what will the formula? I'll tell you when I'll show you some examples. So element towards the left of minus 3 is only 0. Left of 5, 0 minus 3, minus 3. Left of minus 4, all this it's 2. Okay, so what the formula is, if you guys can guess it, please guess it out. Left of I is equals to left of I minus 1 plus array of I minus 1. Okay, so now let's suppose this is I, these both are I minus 1. If I add them, it will be minus 2. Over here, I will add them, it will be minus 4. Over here, I will add them, it will be minus 1. And over here, I will add this both, it will be 0. So this is our formula. Now let's check out for the right subarray, I mean the right array. Obviously the first element will be 0. The elements right towards the 1, only one element is 0. Towards the 3, 1 plus 0 is 1. Minus 2, 3 plus 1 plus 0, it's 4. Now over here, what the formula will be? Right of I is equals to right of I plus 1 and array of I plus 1, obviously. Means for this index, this 2. For this 2. For this index, this 2. For this index, this 2. Okay, so now we have done this, we have reached this step. Now just a final step we have to perform. What we have to do is we have to traverse both the arrays simultaneously, the left one and the right one, and we have to write down all the indexes where both the values are same. Means I will start from here, 0 0. Oh, it's same. This index is 0. 0 minus 3, 0 and 3 are not same. Minus 3 minus 2 not same. 2 and 2 same index, same element at same indexes. So 3. Minus 2 4, minus 4 1, minus 1 0, 0 0 again same. So this is a simple intuition, but the problem here is the time complexity is often and space complexity is also often. We can do it better by considering big O of 1. How we can do that? Okay, you guys just take a minute and think over it. It's a pretty simple solution, I would say. Okay, what we will do is we will maintain two variables, namely total and left. Left will be obviously initialized to 0. And what will total contain is, total will also contain the sum of all the elements, and in this case it is 0. If you guys want to check it out, you guys can check it out. Okay, now what we'll do is the formula we'll apply is if total is equals to total minus the current element and the left. Why total minus the current element and left? Okay, I'll give you an example over here. Let's suppose I'm at this index. Okay, now what I have to find is if this and this are equal. But what will total contain? Total will contain all this sum. So what I'm subtracting is A of I, means I'm subtracting this element and the left. Left means it will contain all these elements. So in short, I'm clearing all these elements out. So I will get only this. Like, oh my bad, sorry. It should be left. Yeah, it should be left. Okay. So I will be clearing all these elements and then we can find out. Okay, in short, this is the right. Okay. Now we'll start our traversal. Okay, so what we'll do is we'll start traversing from our left, obviously, and we'll apply this formula. What is the value of left? Value of left is 0. Is it equals to what is total is 0 minus the current element plus left? Yes, all this is becoming 0. So yeah, this is our element. Okay, we'll store it, this index. Now let's jump to the second index. And after this we have to add this value in our left. Okay, don't forget that. We have to add this value in our left. So we'll jump to the -3. Okay, what is the value of left? It is 0. Total is also 0. And we will subtract -3 from it. Okay, and so this value is getting to 3. 0 is equals to 3. No, it is not equals to. And we'll add this element to our left. Coming to 5. What is the value of left? -3. What is the value of total? It is 0. Okay. What is the value of A of I? Means this element is 5. Plus left is -3. So this addition is 2. Is -3 equals to -2? No. When this is not an element and we'll add it over here, it will become to 2. Okay. So coming down over here. What is the value of left now? It's 2. What is the value of total? Is 0. I subtract. What is the A of I? Is -4. And what is the value of left? It's 2. -4, it's -2, and outside a minus sign means it's 2. So 2 is equals to 2. So this is my index. Okay, now you guys might got have an idea that how this thing is going to work. Okay, so this will go on. This will not be index, this will not be index, this will not be index, and also this will be our final index. So this is a simple intuition where the time complexity of O of n and space complexity of O of 1. Alright, so let's jump to the code. This is my main function. I've written down the same example which I explained to you guys, and I've given a call to the function called find equilibrium index. As I mentioned, total I'll take it as 0, and left also I'll take it as 0, and I'm adding all the elements. In this case, fortunately, it's 0, but in other cases it might result to something. And here I've taken a list, an array list, for showing the indexes. As I said, what condition I will be comparing? If left is equals to total minus the current element plus the left. Okay, and if the condition satisfies, I will store it in the list. Otherwise, whether or not the condition satisfies, I have to add that element to the left, and after that I will print the list. So let's see how this code works. Yeah, the indices are 0, 3 and 7. If you guys are preparing for Amazon, I have mentioned the link for the Amazon interview playlist which I have created on the top right corner right now. You guys can watch it it will be very helpful for you guys. If you guys love the content which I'm creating, give a thumbs up. I would really appreciate it because it takes some efforts in creating these videos. Please subscribe to the channel. Thank you and stay safe.